Good afternoon. In this video we're going to set up logic cell game number 2, and we're going to create a new work cell, handling pro, call it what it is, pick your version, and pick your tooling. So we're going to go to the 3-jaw if it's not already there. So we're going to go to grippers, find the 3-jaw chuck, and we're going to use the R2000 IC 165F. And we're going to continue next, and then finish. And then we're going to allow this teach pendant to update. So the question about flange type, we're going to do standard. So we're going to go 1, enter, and allow the cell to initialize. Now that the cell is initialized, let's start putting together the cell, and this cell is the same between all the different logic games. So the first thing we're going to do is we're going to add a plate underneath our robot. So we're going to move our robot up 500 millimeters. So we bring her up, and we're going Z 500. So we're now 500 off the ground, and we're going to add a robot table to this. So I'm going to go to cell, and we're going to go to obstacle, CAD library, and we're going to go to robot bases, and we're going to use the first one here, which is the 2907904 X3777. We're going to bring it down so that the Z is 0, and we're also going to change the size of this as well. So the size in the X is going to be 1.25. The Y is going to be 1.125, and then the Z is going to be 1. So when I hit apply, it now should fit perfectly on the base with a little bit of extra all the way around. So now that we have this, we're going to then lock our location and hit OK. Next, let's add the table. So we're going to go cell, and we're going to add fixture, and then we're going to go CAD library, and we're going to find the tables. And we're going to find the table with legs. And we're going to modify the size so that the X scale is going to be 1.25. The Y is going to remain 1, and the Z is going to be 2. Then the X is going to be 1600. The Y is going to be 0. Z is going to be 800. The W is going to be 90. The P is going to be 0, and then the R is going to be 90 as well. And when I hit apply, it should be directly in front. And I'm going to lock the location of this. Hit OK. Next thing we're going to do is create the part. So we're going to go cell part. And we're going to create a simple cylinder. And we're going to change the size from diameter to 50 and 100, and we're going to have a 2 kilogram mass for this. Okay, so now that we have the main cell set up, let's now set up our main U tool. So let's double click our 3-jaw chuck. Let's go to U tool, and let's just make sure that the triad is the correct direction, whereas the Z plus is up, Y is to the right, and then X is forward. Let's go edit tool, and let's just double check everything. Looks like everything is good, so we're at 415 Z, W 180. So if you need to modify that, you can use current triad location and modify these numbers. So let's hit apply on that. Let's go to parts, and we're going to add a part. Let's hit apply on that so we can see our part. Now we need to modify the rotation of this. So we're going to edit part difference, 415, and the W needs to change to, we want to modify so that the triads are the correct direction. Right now it's downwards, so we need to modify this to -90. And now we have our triad Y positive. And we just want to make sure that these are matching when we add it to the tabletop games scenario. So the Z is going to be to the left, the X is facing forward, and the Y is facing up. So let's hit apply on this. Let's hit OK. And now we're going to set up the actual jaws. So we'll hit the plus next to the 3-jaw gripper, and let's double click jaw number 1. And we want to make sure that all these match. So it should be 0, 0, 0, 0, negative 90, 0, and those should be all good. We're going to go on the Z-axis. Let's go to the motion. We're going to switch this to device in and out, linear motion, and we're going to go speed of 1000, both forward and back. It's going to be a very quick speed, and we're going to be using robot controller number 1, and we're going to use digital 1 for our opening and closing. So one's going to be on, one's going to be off. So when it's on, it's going to be at our open position, and closed is going to be at 20. And we can test that to see what that looks like. So off means it's open, on means it's closed. So if I go test, you can see it move open, and then if I go up here and go test, you'll see it go closed. So the open and closed. And then for the outputs, we only need to put this on one of the jaws because they're going to go at the same exact speed. So this is going to be digital input number 1, and this is going to be digital input number 2. And both of them are going to be on, so location is going to be 0 and location is going to be 20. So again, we only need to do this for one of the jaws. So I do it for the first one, and you don't have to do it for any of the other ones. So I'm going to hit apply and OK, and let's set up the second and third jaw. So the same exact thing, go to the motion, and we're going to do a device in and out, linear motion, speed of 1000 millimeters per second, 1000 millimeters per second. Output device is going to be still the digital controller number 1, so that they all turn on and go at the same time when we call for it. There we go. So now that is open. Now we're going to go to the next one. Remember, we do not need to put an input or an output. Let's go to jaw number 3, and we're going to go device in and out, linear, speed of 1000. Robot controller number 1, and then digital 1, digital 1. One's going to be on, one's going to be off. Off is going to be at 20. We do not need to put an output. So let's hit OK, and everything is now set up for our jaws opening and closing. Let's create the simulation program for the gripper open and close. So let's go to Teach, Add Simulation Program, and we're going to call this one Gripper Open. And when the gripper is open, we're going to utilize digital output number 1, and that's going to mean we're going to be off. So we're going to wait for digital input 2 to be on. So digital 1 off, wait until digital 2. So we're hit play on that. Should remain open. Then let's start the close process. So we're going to go Teach, Add Simulation Program, and we're going to go gripper closed. Hit OK. And we're going to go digital output number 1 to be on, and we're going to wait for digital 1 to be on. And when I run this program, it should close. There we go. So now we have our opening and close program to call. Let's turn on Teach Pendant and set up some position registers. So I'm going to go to Data, Type, Position Registers, and we're going to go, first one is going to be Home Position. Next one is going to be Safe Position. Third one is going to be Game 1, so this will be the logic cell number 1. Starting point. Game 1 end. Then we have Game 2 starting point. So I have my start and end for all 3 games because again, this cell is the same startup. It's just the board is just a little bit different. Then for position register number 10, we're going to do our tool offset. And then going down to number 12, this is going to be our game offset. So this is going to be game 1 X, Y offset, or you can just call it offset. So now we have all our position registers set up. So let's just record all these. So I'm just go shift record, shift record, shift record. And right now they're all going to be the same until we actually set up everything. So now I'm going to actually go into the home position. So I'm going to go to position, and our home position is going to be 159.2.0.671.0.0.0. So this is our home position here. For our safe position is going to be 0.831. We'll just go 832. 356. 0, 0, and then -90. And if you want, you could just go move to, which will move to our safe position. Let's go to our tool offset. So go to position, tool offset is going to be 0, 0, 0, 0, 0, 0, and then we're also going to change the Z tool offset to 200. And let's go to the game 1 and game 2 offsets. Let's go to position, and let's make that zeros down the board. Let's go to game 2 position, zeros down the board. And game 3 position, zeros down the board. Go to type. Let's go to normal data registers, and here we're going to type in, the first one is going to be our speed, then we're going to have our column counter, then our row counter, and if we need to, counter number 1, and counter 2. And speed, and we just set to 2000 right away. And the rest will be utilized inside the actual program, so we can remain as 0. So now, this is where the two cells are going to kind of start parting. So in logic game number 2, logic game number 3, this is where the board is going to be different, and the position registers for the start and end is going to be different as well, along with the programming. All right, let's grab the CAD file. So let's go to the YouTube page and go to the About, and go under Cell Setup, Logic Game 2 and 3, and there you'll find a folder called Logic Game 3, Cell Setup. Download all these items, which has all the pictures, including the object files for the tabletop. Download them, and then place them into your folder. Logic Game number 3, I copied it into that folder where all my pieces are for that cell. And I have everything inside that cell, so that's where we're going to pull from. So let's go inside here, and let's bring in the game parts. Let's go to cell, fixture, and then we're going to go to single CAD, and we're going to go to my work cells, game 3, and go to that folder, and find 3.1. Go to general, and then we're going to place the sizes of 1600, 900, 800, 90, and 90. And when I hit apply, it should be right at the bottom here. Lock locations, and hit OK. Next, we're going to bring in the top portion. So let's go to Cell, Fixture, Single CAD Library, bring up 3.2, and let's put in the sizes, same as the other one. The top, lock proportions. Let's add the part. So let's go to parts, part, apply, and let's edit the location of this so it's in the correct place. So we're going to go 8, -862.5, 40, 50, 0, 0, 0. So the Z is in the correct direction, X is in the correct direction, and also the Y is in the correct direction. So this is going to be placed here, so visible at runtime, so that's good. Simulation, we're going to allow this to be picked up. Uncheck placed, and we're going to create after 2 seconds from being picked up. So pick up, 2 seconds later, we're going to place. Hit OK, and now let's go to the main board. So let's go to parts, and let's check this part and hit apply. And this is not going to be visible at runtime, so uncheck that, hit apply. And we're going to go to simulation, click the part, and we're going to allow this to be placed. So click here, and we're not going to destroy this. Hit apply. So now let's go back and array this. So let's first make sure the part's in the correct direction, or in the same right place. So go negative 1262.5, 40, and negative 200. And it should be in the corner, so that's all good. Hit apply, and let's go add. The Z direction is forward, the X direction is to the right. So the X direction we need a total of 9 columns, and then the Z direction we need to have 5. So when we hit OK, with the 100 millimeters, we should have all our correct number. We need to go through and uncheck the ones that we don't need. The last 4 in row 1. So we need 2, 1 here, and we don't need 2, 3, 2, 4, 2, 5, and we need 3 now. So 3, 1, 3, 2, 3, 3, and 3, 4, 3, 5 gets unchecked. And then the last row here, row 4, we're going to uncheck 4.5. And then on the other side, we're going to go the opposite. So row 5 is all good. Row 6, we need all 4 except the last one. And then row 7, we're going to uncheck the last 2. Row 8, we're going to uncheck the last 3. And row 4, or the last row, which is row 9, we're going to uncheck the last 4. And when we hit apply, we should have a triangle. There we go. Hit OK. And we need to set up the position registers for the start and end. Data. And I'm going to go to type, position register, and we're going to go game 3 start. So game 3 starts right here. Double click our starting point. And then under parts, we can go move to. And this is where we're going to go shift record. So now that position is recorded. Let's go to game 3, the end. Double click our part here. Go to part 1, 1. Go move to. And we're now moved to that corner. So we're going to go shift record for our game 3 end. Hit OK. Let's create our 2 simulation programs before we go to teach pendant. So let's go teach, add simulation program, and this is going to be called our end drop off game 3. And all we're going to do is go to drop the part from gripper 3 to logic game 3_1, and then part asterisk. Make sure it says asterisk there. Then let's go to teach, add simulation program, and this one is going to be our pickup area. So start game 3. So we have our start pickup game 3. Hit OK. And this one we're going to switch to the pick up. So we're going to pick up the part from game part number 3.2 and then with the gripper. So now that we have our simulation programs done, then you need to create the teach pendant programs, much like in game 1 and game 2. So inside that folder, you have game 3 part pickup. So here's the teach pendant for that. So calling out the frames, you're going to move to that position, then you're going to drop off the part or pick up the part. So you're going to call the gripper closed, call start pickup game 3, which we just created. Both those calls are the simulation programs. And here is game 3 part place program. Same just as the part pickup, but instead of picking it up, we are placing it. So we're calling the two simulation programs, the gripper open and also the drop off program that we just created. Again, both of these are simulation programs, utilizing tool offsets and speeds that we have created from the previous areas. And then the final answer. Again, utilize this if you need to. Again, this is not the only way of doing things. Just keep that in mind. So this is game 3 answer. This is the way I did it. So I have all my variables. I have my speeds overrides. I have my home positions and then my loops. So here's my loops, the pickup areas, offset areas, loops, pickup, offsets. And I keep going down all the way to the bottom. Again, you do have this at your disposal if you need help. And when you're done programming it, you should have the pick and place of the triangle. So good luck.